Today we are going to study about the efficiency of the transformer. So efficiency, be it of any electrical device, whether transformer, generator or motor or anything, you take it, anything electronic device consist is formula, it has the same formula, that is output by input. So efficiency is what? Input. So we can take input as output. Input comprises of what? Input, output plus loss, means the input power that you have supplied will get some output comprises of, and in relation with loss also. So efficiency we can write as output by output plus loss. So from here, so efficiency output, and what are those losses? Those losses are copper losses or iron loss. So we can write either way around formula, like in output what we can write? Input minus loss. Simple algebraic relation, from we can write output as input minus loss. So here we can simplify. Now we'll see the maximum condition for the efficiency, means when transformer performs the maximum work. For studying the condition for maximum efficiency, we'll take copper loss as I1 square RO1. RO1 is what? Equivalent resistance referred to primary winding. Or we can take I2 square RO2. RO2 is what? Equivalent resistance referred to secondary winding. But while further deriving the formula, we'll take primary winding as our study. We can take either secondary winding also, but doesn't matter. Now we denote the copper loss, any loss in transformer we denote by W, or any beat any electrical machine, we denote it by W. So WCU means copper loss, and iron loss comprises of hysteresis loss and eddy current loss. You all have studied in our previous videos what is hysteresis loss and eddy current loss. So what is hysteresis loss? Hysteresis loss is denoted by WH. W means loss in any loss in electrical machines, and H by hysteresis, and similarly eddy current loss. The whole will give the iron loss. Now considering the primary side, we are going to study about primary side. So primary input is what we have input, what we have given input is VI cos V1 I1 cos phi 1. What is V1 I1 cos phi 1? It is input power. Now so we can put these values in our formula. What is our formula? We have studied earlier that efficiency is input minus losses upon input. So what is input? Input we have taken here, and this is input. Now what is copper losses? Copper losses we have already seen that I1 RO1 is I1 square, RO1 is our copper loss. Since why we are taking RO1 and I1? Because we are taking it, studying our primary side now. And WI matlab copper iron loss. So after simplifying we'll get this one. Now simple give a differentiation with respect to I1. So after differentiating we'll get this relation. You all know simple differentiation. Now if we are going to find the maximum efficiency, so how we can find maximum efficiency? Maximum efficiency is something that if we have studied that in our the graph, that maximum efficiency, anything maximum, if we find in differentiation, that will give the slope 0. So slope here should be 0, means differentiation of efficiency with respect to I1 should be 0. So after substituting this as 0, so we'll get the relation as RO1 by V1 cos phi 1 is equals to WI upon V1 I1 square cos phi 1. So after simplifying we'll get W1 is equals to, means WI copper iron loss is equals to I1 square RO1 or I2 square. So here what we have seen, copper loss is equals to iron loss. So when we will give, so we can calculate that when we'll get the maximum efficiency. Maximum efficiency we'll get at when copper loss is equals to iron loss. Thank you.